Hello everyone. In this video, we basically go through the interface builder of Device Studio GUI where we can create interface between two different materials. You can see the interface between Fe2O3 ZNO and ZNO nickel, Fe2O3 MOS2 and Fe2O3 graphene. When we talk about the interface builder, it is a tool for constructing interface between two different material structure like structure A and structure B. You can see in the interface builder GUI also like structure A and structure B. It is basically used in computational material science to align lattice for the heterostructure, and the key goal is to minimize lattice mismatch and defect. Constraints during create interface between two different material like minimize the lattice mismatch, create the supercell with small n cross m, and rotation constraint, also small rotation, symmetry and surface orientation, vacuum and thickness. Let's jump to the device studio and see the interface builder GUI first. Open the file explorer, our device studio GUI D folder, device studio, you can see in bin folder, device studio application. Double click. Let's create a new project first. Give the name like interface. This is a device studio GUI where you can create your material, simulate your material file, and delete, add atom, and some structure modification also you can perform here in this GUI and also simulate here. If you go to the build option, here you can see interface builder option. Click on this. It will open the new window with name interface builder. You can see some parameters like structures where you can import structure A and structure B, surface order also, and constraints like grid size, rotation, and strain. Let's understand these parameters. After that, we import some material file and showcase the interface between two different material. If you can see, first we have to import structure A, like choose material like MOT2, and in structure B, in the same way you can import graphene or nickel or other material you can also import, and in the same way you can see surface order. Surface order define the orientation basically in which direction like Z, X and Y, and alignment also for the interface alignment, and you can see the matching of A with B. In the same way for the grid size, you can see you can assign the grid like 6 cross 6 for the interface vector, and same way define the possible combination to test the matching also. If the larger range, it means more possible supercell but more computational. If n is equal to 6 and m is equal to 6, means it will try the combination up to 6 cross 6 supercell. You can see. In the same way for the rotation also, you can see the scan angle from 0 to 180 degree and increment of 4 degree you can see, and you can also test rotational alignment to find the best fit between the surfaces. After that you can see strain. In the next slide we will learn about the strain concept. Basically strain is the when you join two different material like A and B, their lattice constant, unit cell size basically, are usually different. To make them fit at the interface, one or both material must be stretched or compressed. Basically this deformation in material what is called the strain. Basically you can see tensile strain means stretching of material, and compressive strain squeezing, it means compress the material, one material. Strain range maximum allowed mismatch, if you decrease the below 5% is realistic, and if you increase the 100% it means it's unphysical, too much distortion occur. Let's see in the GUI first. Then if you can see the strain range, it's 100%. It's basically unphysical. If you keep the 0 to 5 in between, it will be realistic. And you can see the strain surface also, strain first surface, second surface, and both surface. It means to talk about the strain first surface, it means structure A will be stretched or compressed. The same way if you consider strain second surface, it means the second surface, the structure B will be stretched or compressed. In the same way if you consider strain both surface, then the both structure A and structure B will be stretch or compress. You can also see in this diagram, three diagram like strain first surface, strain second surface, and strain both surface. Let's jump to GUI and create some interface. Go to the file option, then import some material file like import local. Let's import from the 3D material, then conductor, pure metal. Let's import silver first. Let again go to the file, then import local. In 3D material, go to the conductor, pure metal, and this time import gold. Click on open. Go to the build option, interface builder, and click on this and import silver first, then give the gold, and surface order will be Z. In the same way for the structure B also, and of some constant like grid size, give n is equal to 6 and m is equal to 6 also. Rotation from 0 to 180 degree and increment of 4 degree, and strain range will be 5%, and strain first surface will be. Click on match. Here you can see the mismatch is the 1.43%. Click on preview, and now you can see the interface between gold and silver. Click on build. Let's create another interface. Again go to the build option, interface builder. You can also import material from this 3 dot. Click on this. Go to the material folder, 3D material, and go in the magnetic material. Import MNSV, and same for the structure B. Click on 3 dot. You can directly import material from here. Again go to the material folder, 3D material, novelty material, then in topological insulator, click on sp2te3, open. This time increase the n range and m range, and scan angle from 0 to 180 and increment of 4 degree. Strain range will be 5%, and strain surface is strain first surface. Click on match. You can see the mismatch 0.45%. Click on preview. You can see due to large number of n into m, it creates a large supercell, and number of atom also increase. It take computation time also. Click on build. You can see it create interface between MNSV and SB2E3. Let's create another example. Go to the file, import local, and in 3D material, go to the metal oxide and click on zinc oxide, open. Again go to the file, import local, and in 3D material, go to the conductor, pure metal, and import nickel. Click on open. To create the interface between zinc oxide and nickel, go to the build option, interface builder, and choose zinc oxide and nickel, and n will be 6, m also 6. Scan angle from the 0 to 180, increment of 4 degree, strain range 5%, and strain surface will be the first surface. If you click on match, you can see it shows the theta different. Click on OK, close this, and if you click on zinc oxide, go to the build, symmetry. You can see the crystal system is hexagonal, and if you click on the nickel and go to the build, symmetry, you can see the crystal system is rhombohedral. Both crystal system are different. To solve this problem, convert nickel into hexagonal. To convert nickel into hexagonal, go to the convert to crystal option. Here you can see, click on this, user defined, click on hexagonal, and click on build. Left click of the mouse, drag a box, and click on center. If you go to the build, then interface builder. Now if you click on match, you can see mismatch is 1.69% and click on preview. You can see it create the interface between zinc oxide and nickel. Click on build, create the interface between zinc oxide and nickel. Let's create the fourth interface. Again go to the file, import, import local. This time import 2D material, graphene, and the second material will be go to the import, import local, 3D material, go to the metal oxide and let's import Fe2O3. You can see, go to the build, interface builder, choose graphene for first structure A and for structure B click on Fe2O3. N will be 6, M also 6, and scan angle from 0 to 180, increment of 4 degree, and strain range will be 5%, and strain surface will be first surface. Click on match. Go to the file, import, import local, go in the 3D material, metal oxide, import Ag2O3. Again go to the build option, interface builder, let's choose gold, then Ag2O3, and N is 6, M also 6, and scan angle from 0 to 180 with increment of 4 degree, strain range 5, and let's consider the strain first surface. Click on match, theta different. Go to the build and see the symmetry option of Ag2O3. You can see it's so cubic structure, crystal system, and Au. Go to the build, symmetry. You can see rhombohedral. To convert, go to the convert to crystal option, click on simple cubic and click on build. Left click of the mouse, drag a box and click on center. Again go to the build, interface builder and click on match. Here you can see mismatch 1.27%. Increase the grid size also, then match. Now you can see mismatch 0.44%. Click on preview. You can see, click on build. Interface between Ag2O3 and gold. Sometimes same crystal system didn't form interface because of their lattice mismatch and angle. Sometimes also when different crystal system like hexagonal and triclinic, they form interface because of small lattice mismatch and rotation angle. I hope this video is very useful for you. See you in the next video.